First of all, do any of you have a turtle? In that tank over there is a turtle or red-eared slider, and he always acts like he's starving. We bought him from a guy on Hollywood and Vine when he was like this big, and now he's like this big. So anyway, anybody who has any turtle facts, pass them on. Today, as promised or maybe threatened, we are going to continue talking about sampling distributions and the standard error. In this case, we're going to talk about the standard error of the difference between means, not a mean, but the difference between means. Main thing to remember about that is there's going to be two possibilities for error. So let's back up. Say you're getting a sample, and that sample you're finding the mean, and the mean you find probably isn't going to be exactly equal to the true mean of the population. What's the average amount by which the mean that you got for that sample is going to differ from the population mean? Well, that depends on the variance in the population, which you don't know. So you're going to estimate that by the variance of your sample and the number of people you sample. The average amount by which your sample mean is going to differ from the true population mean is the standard deviation divided by the square root of n. Talked about that previously. Let's look at a real life example, the Hopi infants versus Sioux infants. Now, this was a study done quite a while ago. They did not separate out Lakota, Dakota, didn't separate out by reservation. So they have at least recognized that not all Native Americans are the same. And one of the differences might be that there is a mean difference in birth weight. And they specifically looked in this study at the mean birth weight for Hopi baby boys and a bunch of other groups. But they looked at boys versus girls separately because they had different mean birth weights. So the mean birth weight for Hopi baby boys in the US was 7.04 pounds, about 113 ounces, with a standard deviation of about 17 ounces. And then 338 babies that they weighed. And then the mean for Sioux baby boys was 7.6 pounds or 122 ounces with a standard deviation of 21. And they weighed 3,437 little baby infants. And these data are from 1973. Now, remember when we talked about the whole research design chapter, that was over 50 years ago. Perhaps you cannot generalize from then to now, but for the purposes of this example, with real data, we're going to go for it. Now, the variance of the sampling error of the difference between two means is shown as this. The variance of the difference between mean one and mean two. So that's the variance of the sampling distribution for the second population, variance of the sampling distribution for the first population. And another way to look at that is it's the variance for group 1 divided by n minus 1, variance for group 2 divided by n minus 2. To get the sampling error of the difference between two means, you take the square root of the variance, just like the standard deviation is the square root of the variance, right? We have here the standard error for group 1, so variance group 1 divided by number in group 1, variance group 2 divided by number in group 2. If we want to get the sampling error, not variance, we take the square root. And now we do this because we have two possible sources of error. We took a sample from one population, the Hopi boys, and they probably didn't exactly equal the mean for the population, so there's some error. We took a sample from a second population, the Sioux boys. They, again, probably don't represent exactly the true population mean, so there's some error in both cases. Now let's use our example and work through this equation. We're going to find the variance for the first group divided by the number in the first group plus the variance for the second group divided by the number in the second group, and we'll take the square root of that whole thing. We have 289, 17 squared, right? Because the standard deviation for the Hopi boys was 17, so we have 289, which is 17 squared. We have 21 squared, which is 441, and we divide 289 by 338. We divide 441 by 3,437, and we get 0.855 plus 0.128. That gives us 0.98. We take the square root of that, and that equals 0.99. That is our standard error of the difference between means. Pulling all that together, the standard error of the mean is 0.99 ounces. So let's round that to 1. The mean difference is 122 ounces minus 113 ounces equals 9 ounces. Would we reasonably conclude there's no real difference in the population? That is, the mean of one group equals the mean of the other group. Well, if we look at this in terms of standard errors, if the true difference between means is 0, and the standard error of the mean is 1, then 95% of the time, we know from our study of the normal distribution, we're going to be between two standard errors, right? 9 standard errors is not even on this graph. It's way the heck out here somewhere. Based on this, I think we would reasonably conclude that the differences between these two means is not 0 because depending on which way you look at it, the mean of the Sioux boys is 9 standard errors, way out there, above the mean of the Hopi boys. Or if you look at the other way, the mean of the Hopi boys is 9 standard errors below the mean of the Sioux boys. And either way, it's not very likely that the two population means are in fact equal.